This is the key to topic 26, part A, worksheet 1. And on this worksheet, it says for each rational function, determine the domain and any vertical asymptotes. Then write the domain in both vertical and set builder notation. Also determine if there will be any holes in the graph and the x value where the holes occur, if there are any. All right, so let's look at number 1. So in number 1, we have f of x is equal to 3 divided by x plus 5. So we have this rational function. And first of all, to determine the domain, we're going to do this. So the domain, to determine the domain, you look at your denominator. Now remember, you can never divide by 0, right? And so we got to determine the restrictions. So first of all, the restrictions, to determine the restrictions, we're going to set this denominator equal to 0 because we need to determine where is this equal to 0. So when I set that equal to 0, I get x to be negative 5. So there's your restriction. So in the number line, when you think about this on the number line, you have negative 5 and you can cross it out. And so the domain then would be every real number except negative 5. So if you look at this in terms of the number line, there are two intervals. So your domain in interval notation, is negative infinity to negative 5, with parentheses because you cannot include negative 5, union, and then negative 5 to infinity. All right, now in set builder notation, you're going to say this. So think about what we just talked about earlier. We said that the domain would be every real number except negative 5, right? So you're going to write like this. You're going to say the set of x's such that x does not equal negative 5. And that's it. All right, so any real number except negative 5. That's what that says. Okay, now let's talk about the vertical asymptotes. So the vertical asymptotes, to determine the vertical asymptotes, you're going to look at your restrictions. That's one thing you're going to look at. So notice that when I look at this function right here, my restriction is negative 5. So that means that x cannot equal negative 5, right? So that's going to be one of my domains. One of my vertical asymptotes. Now also keep in mind that in terms of holes, you need to ask yourself, is any of these restrictions going to occur at a hole, H-O-L-E? And to determine that, you're going to look at your numerator and denominator and notice that the numerator and the denominator have no common factors. And so there are no holes here. So there are no holes. Okay, no holes. So my vertical asymptote will occur then at that restriction right here. So remember, the vertical asymptote is a vertical line. So you name a vertical line saying x equal. So you have to say x equal negative 5. All right. And so the question is, does this function have any holes? The answer is no. So no holes, because this restriction we obtained from this factor right here, and this factor does not occur in the numerator. Okay? So that's number 1. Now, okay, I just wanted to show you what the graph of this looks like. So here's your graph, and notice you see your vertical asymptote right here. So there's your vertical asymptote at x equal negative 5. So x equal negative 5 is your vertical asymptote. Now, in one of the next worksheets, you're going to talk about horizontal asymptotes, how to find those. But for this worksheet, you're just interested in determining what are the vertical asymptotes. And I want you to also see the domain. So when you look at the domain, remember the domain is a set of x coordinates. So as you go from left to right, see this arrow? So you're going from negative infinity all the way to negative 5, where the restriction is, where the vertical asymptote is. And then from negative 5 all the way, and see this arrow keeps on going all the way to infinity. And notice that this is the domain you found. Okay? All right, so that was number 1. Okay, so number 2, we have this for number 2. We have x plus 7. So let's see, f of x equal x plus 7. divided by x minus 10. All right, so x plus 7 divided by x minus 10. And again, you want to find the domain in both interval notation and set builder notation. Just like we did before, notice that the denominator, to find the domain, you look at the denominator. The denominator, there's just one factor here, x minus 10. So we're going to look at the restriction. So what is the restriction? So the restriction, I'm going to determine that by setting that equal to 0. And when I solve for x, I get x to be 10. So that's my restriction. So if I put 10 on the number line and cross it out, meaning I cannot use it, then my domain would be every real number except 10, right? So I would have two intervals, every real number except 10. So in the domain in interval notation, is from negative infinity to 10, and then from 10 to infinity. So from negative infinity to 10, union 10 to infinity. In set builder notation, this is how you're going to write it. Set builder notation. You're going to say this. Remember the set of, it's all real numbers except 10, right? So you're going to say the set of x's such that x does not equal 10. All right. Now, the next question was the vertical asymptotes. All right. So the vertical asymptote, remember, your vertical asymptote, to determine that, you're going to look at the restriction, but remember, sometimes that restriction can be a hole instead of a vertical asymptote. So to determine that, you look at your original problem and see if any factors can be reduced. All right, so in this case, there's none, because this is x plus 7, this is x minus 10. So that means that this restriction is your vertical asymptote. So you're going to say x equal 10, and there are no holes. Okay, so that was number 2. All right, let's look at number 3. So number 3, we have this function for number 3. All right, we have 3x f of x equal 3x minus 1 divided by x squared minus 9. All right, so to determine the domain, we need to determine what value of x makes the denominator 0. And so I have x squared minus 9 equals 0. Now notice this is the difference of two squares. I could do one of two things. I could bring the 9 over and take the square root of both sides. Or I can just factor, just like I'm doing. X minus 3, x plus 3 is the difference of two squares. And so I get x minus 3 equals 0, x plus 3 equals 0. And so my restrictions are that x cannot equal 3 and x cannot equal negative 3. So I'm going to put that in the number line. Make sure you put it in order, negative 3 and 3. You're going to cross those out. And so my domain will be all real numbers except negative 3 and 3. So in terms of interval, you have 3 intervals here. This interval, that interval. So your domain in interval notation is going to be from negative infinity to negative 3, union, and then negative 3 to 3, union, and then 3 to infinity. The domain in terms of set builder notation, you're going to say the set of x's such that x, and you just say cannot equal 3 or negative 3. Can equal 3, negative 3. All right. Now, to determine the vertical asymptotes, for the most part, the vertical asymptotes will be these restrictions except if they're holes. And you would have holes if any of these factors right here reduces with anything above, and they don't. Because if you look at this, if you look at f of x, you get 3x minus 1 divided by x minus 3, x plus 3, and there aren't any common factors. Okay? All right, so the vertical asymptotes. Now it's very important you understand that when writing the vertical asymptotes, you must write it as an equation. X equal 3, x equal negative 3. X equal 3, x equal negative 3. Okay? And so there are no holes in the graph. No holes in the graph. All right, so that was number 3. Okay, let's look at number 4. So when looking at number 4, we have this for number 4. All right, number 4, we have this function. We have f of x is equal to x plus 2 divided by x squared minus 6x plus 8. All right, now before I go 1, let's go ahead and see if this is factorable, because I would have to set it equal to 0 anyway to find the restrictions, right? To find the domain. So let's go ahead and do that. So it'll be x plus 2 divided by, and this will be x plus 2 times x minus, x minus 2 times x minus 4. All right, and so that's how I factor this. And notice there aren't any common factors at all. So there aren't going to be any holes, no holes, since there aren't any common factors. Okay, so let's determine the restrictions. So the restrictions, to determine the restrictions, that's where you cannot divide by 0. So we've got to set this equal to 0. So I get x minus 2 times x minus 4 equals 0. Then we set each one equal to 0. Right, using the zero factor property. So I get x to be 2, x to be 4. Now remember, since there were not any common factors, then these restrictions will definitely be your vertical asymptotes. All right, so let's first of all put that in the number line just to kind of help us determine the interval notation. Put them in order, cross them out. And so notice that these two restrictions divide the number line into 3 intervals. And so the domain in interval notation as an interval will be from negative infinity to 2, with parentheses for 2, because 2 is a restriction. You cannot use it. 2 makes the denominator 0, so it's undefined. From union 2 to 4, and then union 4 to infinity. So basically what you wrote is that the domain's any real number except 2 and 4. And the domain, in terms of set builder notation, you're going to say this: the set of x's such that x does not equal 2 or 4. You can write it like that. Okay? All right, and then remember there are no holes, right? Oh, I forgot to put the vertical asymptotes. So the vertical asymptotes, you're going to say x equal 2, x equal 4, x equal 2, x equal 4. You must say x equal 2, and you must say x equal 4. And so there are no holes since there weren't any common factors. All right, that was number 4. Okay, let's look at number 5. Okay, number 5, we have this for number 5. We have f of x is equal to x minus 3 divided by x squared minus x minus 6. All right, so when I factor the denominator, let's see, the numerator is x minus 3, and I factor the denominator, I get x minus 3 times x plus 2, right? Now notice this time there are common factors. Now I'm going to go ahead and reduce that now. So when I reduce that, and let me go ahead and rewrite it, x minus 3 divided by x minus 3 times x plus 2. So these divide out, and so I get 1 divided by x plus 2. Now be careful. When finding the restrictions, you must use these two, not just this one, these, okay? So it's what makes the original function undefined. So what makes the original function undefined, okay? So the restriction, you can say x minus 3 times x plus 2 equals 0. So x minus 3 equals 0, x plus 2 equals 0, and x to be 3, x to be negative 2. So your domain will be all real numbers except these two. That's a true statement. But in terms of vertical asymptote, these restrictions, they're not all going to be vertical asymptotes, because you were able to reduce common factors. So this common factor right here, x minus 3, that's the one that's going to produce the hole. And that's, so you can get a hole here, and this is going to be the vertical asymptote. Okay? So keep that in mind. So let's talk about domain now. Domain in interval notation, is this. Okay, so domain in interval notation, you're going to say negative infinity. Oh, let's put this on the number line. It helps if you put on the number line. In order, negative 2, 3, cross those out. You have 3 intervals. So negative infinity to negative 2, parentheses, union, negative 2 to 3, parentheses, union, and then 3 to infinity. All right, and then your domain in set builder notation would be the set of x's such that x does not equal negative 2 or 3. The vertical asymptote, be careful, don't say both of those. Remember, the vertical asymptote occurs at a restriction except where there's a hole. So there's a hole here because x minus 3, and that's how you got x equal 3, x minus 3 factors out. So you get a hole here, and so the other one then is the vertical asymptote. So there's only one vertical asymptote, x equal negative 2, and the question is, does the function have a hole in the graph? Yes, there is a hole. There is a hole in the graph, and it occurs, meaning it, the hole occurs, oops, can't spell, the hole occurs at x equal, let's see, the x value is what they wanted, so x equal 3. Okay? All right, so let me go ahead real quick and just show you the graph of this. Now, you don't know how to graph it just yet, but let me go ahead and show you the graph. Okay, so here's the graph, and so notice there's your vertical asymptote, x equal negative 2, right? X equal negative 2. Remember, you name a vertical asymptote saying x equal. And you don't know how to find this, but there's a horizontal. You're going to find that in the next lesson. And you see there's a hole. So when x is 3, see the hole right here? The hole, let me just kind of tell you, this hole right here occurs when x is 3. And remember, that's when it occurred, right? X equal 3. And then to find the y value, all we did was just in place of x, substitute 3. So I get 1 divided by 3 plus 2 is 5. So you get 3 1/5 as the hole. All right, and remember the graph from our lessons, the graph oscillates towards these vertical asymptotes. See how it's going towards the vertical asymptote here, towards the vertical asymptote here. And remember, it never crosses the vertical, and towards the horizontal on both sides. Now, remember, sometimes it could cross the horizontal. Just keep that in mind. Okay, but it'll never cross the vertical. So there's a graph, and there's a hole. All right, 1 vertical asymptote, not 2. You get a hole here instead. All right, so that is number 5. Okay, now we have one more left, and that's number 6. So let's go to number 6. So in number 6, we have, let's see, number 6. All right, number 6, we have f of x equals negative 2 divided by x squared plus 36. All right, so negative 2 divided by x squared plus 36. All right, so we got to determine the domain. So let's look at the restrictions. So the restrictions. Now, I want you to notice that, see, I cannot factor this. That's the difference of 2 squares. I'm sorry, that's sum of 2 squares, excuse me. That's the sum of 2 squares. So I cannot factor it over the rational, over real numbers. All right, so when I think about the restrictions, what real number makes this 0? What real number makes this 0? You notice I can't factor this, and so some of you may say, well, can I get x squared by itself? Yeah, you can get x squared by itself. So x squared equals negative 36. And then you could ask yourself, well, what real number times itself is a negative 36? And there isn't any. There's no real number times itself that's a negative 36. In fact, if you think about it, and you take the square root of both sides, you get an imaginary number, right? So you get plus or minus, so x equals plus or minus 6i. So that's not a real number. Not a real number. So on the number line, you're not going to put anything there. So the domain is going to be any real number. Any real number is the domain. right? So in any real number you substitute into x will never make the denominator 0. So in terms of the domain, in interval notation, you're going to say negative infinity to infinity. Negative infinity to infinity. And then now for the set builder notation, for the set builder, you're going to say this. You're going to say the set of x's such that x is an element of the reals. So that means any real number. Okay? And then notice that since there's no restrictions, so no restrictions, let me go ahead and write it here, no restrictions. Since there's no restrictions, then that means that there are no vertical asymptotes. So no vertical asymptotes. Okay? And since there's no restrictions, there aren't any holes. So no holes. All right, so no holes and no vertical asymptotes. So you may ask, what does a graph look like? What does that look like? All right, well, let me kind of just give you a rough sketch of it. All right, so here's what the graph looks like. Now, it's very tiny because of the grid lines I'm using, but here's the horizontal asymptote. You're going to see how to determine that, and then here's the graph. So notice there's no vertical asymptotes, no holes. So basically, you have this. So let's say I'm going to put the x-axis here and the y-axis. So the x-axis happens to be the horizontal asymptote. And let's say this is 1 right here, negative 1. Negative 1. So if x is 0, I want to show you what I did. If x is 0, say 0 squared 0, right? So 0 plus 36, 36. So I get negative 2 over 36, which is the negative 1/18. So let's say negative 1/18 is right here, let's say. All right, so negative 1/18 right here. So then remember your graph goes towards the horizontal. So it looks something like this. All right, I'm not drawing this very well, but it'll look something like that. All right, so this right here is supposed to be this. Okay, so that's what it looks like. Notice, but the idea was that you don't see any vertical asymptotes and you don't see any holes in the graph. All right, so that is the key to this worksheet.